The title of our lecture is Setting Up an Experiment. I would like to remind you that we must now create exotic targets from actinides. A uranium target was used to discover the 112th element. For further research, we need targets containing plutonium, americium, curium, berkelium, and californium. That is, targets made up of elements that are obtained in powerful reactors. This results in limited options because there are few reactors with a large neutron flux. We will return to this topic soon. This is the American isotope reactor in Oak Ridge, and this is the SM-3 reactor in Dmitrovgrad in the Ulyanovsk region in Russia. These machines must produce at least 12 to 15 milligrams of material to make one target. Only one target. This is the first condition. I will show later that it will take 1 year of work to make such a small amount of this substance. The second condition is that a very intense beam of calcium-48 is required because the cross-section is very small, and this has never been done before. Here we are faced with a contradiction. On the one hand, it is necessary to use as little as possible of the substance because the substance is very expensive. And on the other hand, it is necessary to obtain a beam of the highest possible intensity. This balance is difficult to achieve, so one needs to look for some kind of technical compromise between costs and intensity. For the experiment, an intensity of 1 microampere of particles was required, which is 6 times 10 to the power of 12 particles per second. But the cost comes to 0.5 to 1 milligrams per hour. Why 1 milligram per hour? Because it is very expensive. At a rate of 0.5 milligrams per hour, the cost of operating the accelerator increases by 10%. And a usage rate of 1 milligram per hour increases the cost by 20%. The sources usually spend more than 20 to 30 milligrams. As a result, we could not perform the experiment because the beam must be used for a very long time, for a few years, in order to create this sensitivity. This is the second condition, which is somewhat unusual. It is not enough to speed up the process. It is also necessary to make sure that the costs are kept as low as possible. Finally, the third condition is that from all the reaction products obtained, these are approximately 10 to the power of 12, completely different nuclei that have nothing to do with superheavy elements. But for our purposes, it is necessary to select only one. That is, it is necessary to create a system that selects one nucleus out of 10 to the power of 12 backgrounds, which is also a difficult task. We will discuss this more later. We do not have time to select one nucleus, since many of these nuclei have a very short lifetime. Therefore, the system must be selective, sensitive, and fast-acting. To establish a full-fledged experiment, all 3 of these conditions must be met, and this is not an easy task. A whole lecture has been devoted to this topic.